Vegetation plots are used around the world to gather information on how climate change affects our plants in relation to forest growth, mortality and function. In Australia, the census of these plots usually occur within a 4 to 5 week period within the dry season. Before establishing the plot for census, it's important to assess the site for any issues with terrain. This could cause problems for the safety of the crew as well as their ability to gather data. Once this has been done, the approval for the site can be gained and a plot can be established. A 1 hectare plot is established by laying down two 100 metre baselines at 90 degrees to each other and placing stakes at every 10 metres along these baselines. All the other stakes are carefully placed in a similar pattern in relation to these baselines, taking particular notice to the angle and distance with a compass and tape measure. Once the plot has been established, it's now essential to train your team. The team members must have a really good base knowledge of their roles as well as have well-established training. There's normally 3 members of a census team: the diameter taker, the note taker and the painter. All of these team members should remain within the same roles for each recensus, as this will limit data variation. Before the census can commence, the diameter taker's measurement of error must be estimated, with all measurements falling between a 3mm difference. 90% of these measurements can fall within 1mm difference, and 70% must be measured exactly. If the margin of error is too wide, then the team member must be retrained. This is because the errors can substantially affect the results obtained by the census. After all team members are competently trained and all equipment is calibrated and up to standard, then the census can finally begin. The main plot is divided into subplots, which each have 4 quadrants. The crew work from one quadrant to another in the same subplot, measuring all stems 10 centimetres or larger at a height of 1.3 metres before moving on to the next subplot. To do this, 1.3 metre measuring stick is used to find the breast height mark on the stem to measure the diameter from. Any bark, moss or other inhibiting factors surrounding the point must be cleared. The diameter taker can then use a diameter tape to measure the stem to the nearest millimetre, and the painter can then place a mark where the point of measure is using chalk or crayon. It's important not to scratch the tree at this stage, as it could cause the bark to swell, which would result in problematic measurements at recensus. The point of measure is then painted with a stencil for ease of identification, and the stem is tagged with an aluminium tag at 1.6 metres. So the point of this is that it's far enough away to not have an effect on the point of measure if the tree reacts to the metal in the nail. This procedure can then be repeated for all other stems within the plot. It's important to note that all stems should be marked facing the same direction in each row of subplots. This allows the crew to easily identify where one row of subplot begins and another ends. Quite often you can come across a problematic tree, such as a leaning tree or a fallen tree. To measure these ones, it's best to consult the team manual for correct procedures. If there's a stem that's on the borderline of the subplot, a judgment needs to be made to decide whether more than half the base of that particular plant is within the plot. If it is, then that stem should be measured. If not, then it should be disregarded. After the plot has been completed, the XY coordinates need to be taken for each stem. One crew member stands at a stake in the centre of the plot and identifies a visible stem. From here, their location is recorded, and the distance from the stake to the point of measure on the stem is recorded using a coulonometer and a compass. This is then repeated for all stems within the subplot. When the census has been completed, the data is then transcribed into the Team Excel templates and uploaded into the Team Network Data Repository. This needs to occur within 7 days of the last collection of data. Recensus occurs in the same 4 to 5 week period of the dry season as the first census. Before commencement of recensus, measurement of error is estimated again to ensure accuracy. The recensus protocol is very similar to the first census. All previously tagged stems are remeasured, and all newly identified stems need to be measured, tagged and recorded. The census protocol used in the vegetation plots does have its strengths and its weaknesses. It is a relatively solid method for monitoring the above ground biomass change in tropical forests. However, because a majority of its results credibility rests on the measurement accuracy of the crew, human error can be regarded as a major weakness of this method, especially if different people are performing tasks at each census. Another weakness that could be considered is that not all vegetation within the plot is measured. If all the vegetation was measured, the results could be a little more accurate, however it would take a much longer time. Therefore, although the protocol involved in performing the census of these plots has its weaknesses. When done right, important information regarding the forest growth, mortality and function of the plants present within the plots can still be obtained.